Hello, Professor. My name is Justine Corsaini, and my student ID is 1014861141. I have loaded my data, my arrest data using Pandas, and I have used here my PD read CSV file name, and this is my length width of these two with the species. Then this is my first 5 rows of my data frame. Then here I have converted the species column from the text labels into numeric values because the neural network needs numbers and not strings. So I mapped the Setosa to 0, Versicolor to 1, and Virginica to 2. And then this is my unique, and this is my 5 elements of iris data with the species of an int. This is my first 4 columns of data frames as data and call the data X. I separated the input features and targeted label. The features are 4 measurements: sepal length, sepal width, petal length, and petal width. That becomes X, and the output label is this species column that becomes Y. I split the data set into training and testing sets using train test split, and I used 80% for training and 20% for testing. So I set a random state. So the split, this is my first 5 rows, my head. And then here I have done, as it is a multi-class classification problem with 3 categories, I converted the labels into one hot encoded vectors using two categorical. So each label becomes something like 001, 100, and 010. Then here I've made my first neural network. So it has 2 hidden dense layers with 100 neurons each using ReLU activation. And the output layer has 3 neurons with softmax activation because we have 3 classes, and I compile it using RMS-prop, optimizer categorical cross anthropoid laws. And then the accuracy of the matrix has been calculated. And the same I did for second model. Um, but this one has fewer neurons compared, and model 2 has 2 hidden layers but only 10 neurons each, and I trained it with fewer epochs. Everything else stayed the similar, so we can compare the performance, and this is the accuracy for that. And for the question for my 10th A on this, how the number of layers of hidden value. So for this, in general, increasing the number of hidden layers or hidden units can increase accuracy because the model can learn more complex patterns. But if the model becomes too large compared to the data set size, it can start memorizing the training data instead of learning general patterns, which can reduce test data. For the second question, do we always suffer from overlifting? No, we don't always suffer from overlifting. Overlifting depends on factors like model complexity, the amount of data, number of epochs, and how well the model generalizes. For this, how can we detect overlifting? So, to we can detect overlifting by comparing training and validation result. If training accuracy keeps increasing, but validation accuracy stops improving or decreases, that's the sign of overlifting. Also, if the training loss goes down, by validation loss goes up. That's another clear sign. For this, how can we reduce overlifting? For this, to reduce overlifting, we can reduce model complexity by using fewer layers for fewer neurons. Use drop down or drop out. Use clear stopping. Train fewer approaches, or if possible, increase the amount of training data. Now, for my 10B. Here I have this is my baseline accuracy down where we can compare. So for my first optimizer, so changing optimizer can change how fast stable the model learns. If accuracy increase, Adam converged better. If decreased, if didn't it didn't fit as well with these settings. For my change number layer, oh by the way, this is the accuracy for my change optimizer. For my change layer, So more layers increase model capacity. If accuracy improved, it learned better patterns. If accuracy dropped, it may be too complex for small data. This is the accuracy. And for hidden units, more hidden units means more learning capacity. If accuracy increased, it captured patterns better. If decreased, it may need more approach or could be starting to overfit. This is the accuracy. For my change approach, so for your more approach means training longer. And if validation goes worse, it suggests overlifting. And for my fifth, this is my batch size affect how weights update. And smaller batch sizes update more often. Usually larger batch size are smoother but generalizes slightly worse. Thank you.